Hola, everyone. Carlos Arriaga here. Version 1 was the prototype. Version 2 is the solution. Today, we're scaling Horizon Navigator into a serverless first governance engine. I've re-engineered the pipeline to move away from managed clusters into an event-driven flow using AWS Bedrock and Pinecone Serverless. So this isn't just about identifying risks. It's about building a scalable, cost-optimized framework that strictly follows the AWS well-architected pillars. So without further ado, let's give it a little bit of rock and roll and let's dive into the build. This is Horizon Navigator V2. For further reference, I'm just going to call it HNV2. It's not a virus or anything like that. So I am evolving risk management from static reactive logs into a system of autonomous governance. So it's a self-healing risk register and it's engineered for true enterprise scale oversight. My vision is to align AI with the global gold standard for project management, the PMP guidelines, because in high-stakes environments, manual audits aren't enough. So I am moving beyond basic automation toward a managed AI strategy that proactively identifies and mitigates risks according to international PMO Gap standards. For this build, I prioritized efficiency by design. I chose a hybrid approach to eliminate cold start latency by keeping the control plane local and the intelligence in the cloud. Doing this, I ensure maximum speed without sacrificing the power of a managed AI infrastructure. Now let's talk about the Horizon Navigator V2 architecture. Let's talk about the orchestration layer. So the entire workflow is managed by the local navigator core. Instead of a full cloud event-driven flow that introduces cold start latency and infrastructure overhead, we use a Python-based orchestrator running locally. We handle data parsing and workflow logic here for zero cloud compute cost. This keeps the control plane responsive and ensures we only hit the cloud for high-value cognitive tasks. It's a FinOps-first approach to pipeline management. Then we have the security gateway. The secure handshake is super important. Before any transaction occurs with our vector store, the local core performs a dynamic retrieval of API keys through AWS Secrets Manager. And by pulling credentials at runtime rather than hard coding them, we align with the security pillar of the AWS well-architected framework. This ensures the system is audit ready for highly regulated environments where clear text keys are a hard no. Then let's talk about the intelligence layer, Amazon Bedrock. So we use Amazon Bedrock for the cloud brain via an API-driven architecture. We offload the compute-intensive work to managed services by generating 1024-dimension embeddings and in performing deep LLM risk analysis. This allows us to leverage enterprise-grade models like Claude 3 without managing clusters or GPU instances. We send raw text that has been obviously previously sanitized, and we receive structured intelligence with maximum scalability and near zero maintenance. Finally, let's talk about the memory layer, Pinecone Serverless. This is our persistent memory, and as I mentioned, it's handled by Pinecone Serverless on AWS. Once the data is vectorized, we observe it directly into a high availability serverless index. This is a true pay-as-you-go model. We eliminate the idle cluster problem entirely, paying only for the vectors we store and the milliseconds spent on queries. This ensures the system scales elastically with the project's complexity. And the conclusion that I have for this is that by merging local Python orchestration with serverless cloud services, we have built a lean, powerful framework. It meets PMP resource optimization standards while maintaining the security and scalability expected of a modern solutions architecture. Now we are going to move on to the elements of the build. And while we go over the elements of the build, I am going to give you the insights for the components, the main components of the architecture, and what I really liked and what I feel that you should pay attention to and take into consideration if you choose to build something like this yourself. And I think that building this has really enlightened me about a number of things that I didn't know before building this. And so I hope I inspire others to follow the same path. So let's go and let's look at those additional elements. Okay, so now I'm going to start showing you the individual elements. Here we have the raw data. This is our risk register, and it's aligned with PMP standards. So this is the knowledge base that the system is going to digest. And the data is extracted from raw meeting transcripts. There is no manual entry for this. I've created a script for this. So I have programmed an international RBS. It's a risk breakdown structure. So the AI uses semantic reasoning to map dialogue into professional categories like technical architecture, legal compliance, financial, governance, security, depending on that, on the case. And the system also scores probability and impact based on detected sentiment. The mitigation strategy is not templatized, and this mitigation strategy comes from Claude Haiku, and it's based on the context for each one of the risks. The fact that I'm using Claude Haiku and that it's based on the specific context eliminates bias from the model. So that's always important for AI governance and the file that we are going to be using as the risk register. Now I want to show you the AWS console and my environment there. So here I'm going to show you first S3. In S3, I have created a bucket for this project. And this bucket serves as the knowledge base or the universal source of truth. The files that I have in this bucket are the files that function as those guardrails for the governance of the project. And they come in the form of a PMBOK and also the PMP readable KE preparation material. These two are excellent for working as guardrails for all the governance that is related to the PMP framework. Inside the bucket, you can also see the risk register, and this is updated locally. This is uploaded, locally from my computer. And that's pretty much it. Now in this section, we're going to look at Pinecone Serverless, which is our persistent memory. So from a FinOps perspective, this is where we eliminate any sort of cloud waste. By moving away from managed clusters, we've shifted to a pay-as-you-go model. We aren't paying for any idle compute. We only pay for the storage and for the exact milliseconds spent on the vector queries. So this is the database that I have. And in the database, you can see the scores that we have here, for instance, for the queries. So the top results are going to show, like, for instance, this is one of the top results, 1.0006. And this indicates a near perfect semantic match to the query. Even the second result at 0.6588 provides relevant high quality context. So this scoring allows Pinecone to filter out noise and only feed the most relevant PMP aligned data to the LLM, ensuring the mitigation techniques that are generated are grounded in the global standard. We are almost at the end of this video, of this build. And here we have the Amazon Bedrock piece. This is the brain of the operation. And I am working with Claude 3.5. I chose it because it's cost effective, it's very fast, and it follows the guardrails, the PMP guardrails very well. It's serverless and it's got zero overhead. The backend handles all the data, and this is where the magic happens, right? So I am going to input a query. The query that I'm inputting is analyzing the risk register to identify a latent risk that the team hasn't explicitly flagged. I'm asking it to provide a PMP aligned mitigation strategy. And so here it goes. Okay, we can see it's working, and we can see that, just a second, we can see that it has analyzed the risk register and it has identified a specific risk. It's telling us about the risk of AI hallucinations and misleading project management advice. It's giving us information about the latent risk. It's giving us also the mitigation strategy. And it's giving us a goal that is to create a multi-layered verification system. So it's actually, this is very insightful, and this is something that I would expect from this application. In the last part of the video, I'm going to show you how I took all of this and I created a local UI just to query Bedrock and Claude more easily. This is the cherry on top. I created this Streamlit UI that basically takes Bedrock and puts it in my local computer. It's a super cool UI that you can create easily, and it works just like the Bedrock UI that you saw earlier, but in your local environment. So it's way cooler. And so let's continue testing it. And this is the last test that we're going to do. This is the query I'm inputting. Assume our transaction volume doubles next month based on the technical concerns in these transcripts. What is the number one system bottleneck that will fail first? And let's see how the model handles it and how long it takes also. So as you can see, it took a bit more than I had expected, but it gave us a very good result. It says the number one technical bottleneck that will likely fail first is the Bedrock API throttling, which has a high probability of causing real-time risk extraction. So as you can see, it's giving us like great results, great insights, and all these insights come from our risk register and the conjunction with Claude 3.5, and also using the guardrails from the PMP methodology. So that's it. HNV2 proves that AI is a strategic asset, not just a tool. It's built for scale, cost optimized, and strictly aligned with international PMP standards. I have left the full product documentation, the scripts, and all the technical details in the GitHub repo linked below. I am Carlos Arriaga, and I build the engines that de-risk the future. If you found this architectural deep dive valuable, please give it a thumbs up, share, and subscribe for more insights on AI governance. Now, I would definitely love to hear your thoughts in the comments. For instance, how are you automating risk in your stack? So that's it. Let's connect on LinkedIn and build what's next. Thanks a lot for watching. See you on the next build.